A very warm morning to one and all present here. Hope all of you are doing well. We have already completed our 3 days of the FDP on artificial intelligence in remote sensing and earth observation. I, Sangeeta Chakravarti, working as an assistant professor in the Department of Artificial Intelligence and Data Science, SMIT, feeling very glad to welcome you all in the day 4 of this FDP. It's my immense pleasure now to introduce our today's speaker of this session, Professor Dr. Chandrasekhar Bhuyan sir. Dr. Chandrasekhar sir is a geoscientist. He obtained his bachelor degree in geology from the University of Burdwan, MTech in applied geology from the University of Roorkee, that we know all, presently known as IIT Roorkee, and the doctorate degree from IIT Kanpur. Dr. Bhuyan is a DARD fellow and carried out a part of his doctoral research at the Friedrich Schiller University, Jena, Germany, through DARD Sandwich Model PhD scholarship. He has post-PhD research experience at University of Cologne, Germany, Jawaharlal Nehru University, and University of Delhi on applications of geophysics, remote sensing, and GIS. Domains of his research includes hydrogeology, environmental hydrology, drought and water scarcity. Dr. Bhuyan has authored more than 35 research articles in reputed international journals, conferences, and book chapters. At present, he is affiliated to Sikkim Manipal Institute of Technology as professor in the Department of Civil Engineering. So without further delay, I would like to welcome Sir on the dais to grace us with his insightful words and enlighten us with his wisdom. The stage is all yours, sir. Please welcome, sir.
Thank you, madam, for such a, you can say, beautiful introduction about me, all nice words. And thanks to all of you for gathering here. So before I start, I would like to understand about your respective background, particularly whether you are familiar with remote sensing, geospatial technologies, only theoretical background, or you also have, you can say, practical experience, whether you have, you can say, research experience in applications of artificial intelligence, and particularly application of artificial intelligence in geospatial technologies like remote sensing and GIS. So because there is a significant gap at present in our understanding about this, you can say, technological development, because this technological development, particularly artificial intelligence, data science, this is actually very rapidly growing and they are entering into the other domains. For example, remote sensing and GIS, we were actually, most of the people were working it since long, but particularly application of remote sensing and GIS in the context of, you can say, artificial intelligence, machine learning, these are actually comparatively new. So that's why I will start my lecture with the, you can say, first of all with you can say some fundamentals of the remote sensing, and then I will enter into the domain of application of artificial intelligence into it.
Sir, F5 मालूम सर F5. ना ये ब्राउजर में होता है. ये तो
Now it is in PDF, so I think.
बंद करे थी ये तो करूँ. राइट क्लिक करे. और ये थे open in Acrobat. और जो open दिया सर. Open with.
Just
এটা এটাও আছে না?
I have
PPT আছে তো?
PPT I have.
নিচে PPT টা করুন।
I think that would be better.
হ্যাঁ PPT।
Out of box thinking capability, more in-depth processing, but not more in-depth knowledge. That is the, you can say, limitation. So, in another way, it has some advantages which are actually disadvantage. So, it has unbiased decision, that is one sort of, you can say, advantage is considered. Human decisions are often, you can say, subjective and biased. So, if you interpret this unbiased decision making as a positive thing, then AI is very, you can say, efficient. It's human beings are driven by emotions. AI has no emotion, because it is a software only. It follows, it functions, it works based on some, you can say, training, based on some commands. So, it ensures accurate decision making based on these commands, based on this, you can say, program. It is actually program. However, sometimes decision making requires emotion, sentiment, and rethinking to cater morality, humanity, and ethics in the judgment and decision making. AI is handicapped in these aspects. Particularly, this is failed in social aspects, where the decision making needs, you can say, some rethinking, considering the sentiment, considering the sensitivity of the issues. Specific challenges of AI. One is data availability. Remote sensing relies heavily on high quality and diverse database. Obtaining consistent, accurate, and up-to-date data can be challenging, especially in remote or inaccessible areas. For example, there are, you can say, springs, waterfalls inside a forest, and you know it. Can you go for a remote sensing based, you can say, study for detection of springs and waterfalls inside a forest? Because of the high canopy, the electromagnetic energy will not penetrate except the radar, except the microwave range. Second, even drone based survey would be difficult when it is, you can say, dense canopy. Not only that, inaccessible areas where ground truth is crucial, that means man-made survey. If you are not being able to provide this feedback to the AI in real time, then there is a gap, temporal gap, time gap. Data restrictions due to proprietary rights or controlled by government agencies limit their availability for broader use. Limited temporal coverage makes it difficult to assess interannual and decadal variability. Sentinel data. Okay, somebody was just discussing with me. Sentinel data. Sentinel data is available since 2014. Okay, high resolution data, but since available since 2014. Now, if you are going for a time series analysis, okay, glacial lakes, for example, just one example I am telling because just this study we are doing for last 2 years. We find that we have data, sentinel data since 2014. Resolution is 10 meter. But the previous data that we are studying since 1987, there is no sentinel, you can say satellite. We do not have 10 meter resolution data. So ultimately, if there is, you can say, data mismatching, if there is resolution are different, you cannot compare one data with another data. In one data, you can, the outer boundary would be very prominent. In another data, it is coarse resolution, it is blurred, and from that you cannot decipher what is the actual boundary. So ultimately, you have to be consistent in terms of your data. So this limited temporal coverages makes it difficult. Availability of accurately labeled data. This is essential to achieve reliable results when training artificial intelligence models. As we have already discussed, that artificial intelligence is, you can say, working based on the training. If training itself is not accurate, then the results that is coming out of this training is not going to be accurate. So ultimately, it is the effectiveness of AI that is being actually challenged. So model trains on outdated or infrequent data due to unavailability of real-time data make them inefficient. Artificial intelligence is totally dependent on two things. One is the accurate data and second is the training. Data and training, training and data. If these two are not accurate, if these two are not timely, if these two things are not up to date, more importantly up to date, then the accuracy will be compromised. So what could be the possible solutions? Improve data collection, invest in satellite sensor and sensor technologies, and importantly, establish collaboration. It is not possible by one agency particularly to collect, to invest and to collect all types of, you can say, data. USA, India, they are the leaders in, you can say, satellite. ISRO particularly. ISRO has NASA also and ISRO also. They have separate satellites for specific purposes. For example, for weather forecasting, India has a dedicated satellite named Kalpana, named after late astronaut Kalpana Chawla. It is totally focused on, you can say, weather forecasting. It is collecting regular basis detailed information about all the weather parameters. If you are downloading data from Kalpana and going for land use land cover survey, you will not get nothing because it is totally focused on atmosphere. Similarly, NASA, its Landsat data, as the term itself is telling, Landsat, that means it is focused on the land. Whereas the NOAA, the sister concern of NASA, the full form of NOAA is National Oceanic and Atmospheric Administration. So in the term itself, you can see it is focused on ocean and atmosphere. So the NOAA series of data, you may get some information about the land parameters, but actually they are focused, they are designed for collecting data on the parameters related to ocean and atmosphere. Landsat on the other hand, it is focused on the land. So, if the, you can say, collaboration is not done to share the data of these different, you can say, parameters focusing on different aspects. OceanSat, Indian satellite, OceanSat is focused on ocean. Econos data, Cartosat is totally focused for high resolution data of cartography, that is mapping. What is the resolution? Not in terms of meter, centimeter scale, that much detail you will get. Now, if another country is not having that data, and there is no collaboration, there is no treaty, there is no sharing of data, you are having the data, we are having the data of that country. But until unless this treaty, the collaboration is not there, they are not going to get the data. And people who are working on those study region, they are lacking those data. So that's why this collaboration is very important for, you can say, successful implementation of artificial intelligence in remote sensing. So collaboration among space agencies, government organizations and private entities will improve data access and sharing for training and implementation of AI models. Training optimization. Imbalanced dataset poses a significant challenge in model optimization for the underrepresented classes. So model may exhibit bias. So I am applying AI, but my data set is imbalanced, outdated. I am not going to get any positive, you can say, output. In fact, the data I will be getting apparently showing high accuracy, but it will drive me towards to the wrong decision making. So achieving optimal performance of AI models in remote sensing demands careful consideration and a solid grasp of mathematics. That is another important aspect. There are, it means the new software is being, you can say, developed. Every day you will find, you can say, new, you can say, tools are coming. But what are their applications, what are their applicability, what are their testing, validation, verification? This is very important, because a software, if you press the button, definitely it will give you some output. But that output, how rational it is, that has to be, you can say, verified, that has to be checked. So possible solutions: optimization of algorithms, development of lightweight models, collaboration between organizations, and leveraging cloud computing. Huge volume of data. We cannot even imagine what is the volume every day it is being produced by all these satellites. So many, you can say, hundreds of satellites are continuously, you can say, roaming and continuously transmitting the data. And there are noises, there are signals, there are processed data, there are, you can say, pre-processed data, there are raw data. So this huge volume of data, if you have to, you can say, use for computing, we need cloud computing. Fine-tuning the learning rate, selecting appropriate batch sizes and determining convergence criteria are critical steps in optimizing the complex models. Until unless the models are optimized, means according to the requirement and according to the ground condition. One model which is applicable to Siberia may not be applicable to Himalaya. Both are cloud, both are, you can say, snow clad. Okay, nowadays even for the climate change model that we are using, the climate model, India does not have a climate model. India is using the climate model of the Australian or of China. India does not have a climate model. So what model is applicable in one part of the globe is not applicable to another part of the globe. The land use land cover model or the guidelines of United States of America is not applicable for India. Because in USA, the farmlands are of several hundred acres, paddy, several hundred acres, wheat, several hundred acres. There is a government control. You can say, and you can say, what you call a farmer in India can decide this year I will not cultivate paddy. I will switch over to crop grass because that will give me more, you can say, money. In USA, you cannot frequently change this. Why? Because the economy, the planning, government planning, it is based on what is the crop productivity, the import, export, everything. It is totally mapped. So, it cannot be based on our whims. So, they have their own land use, land cover, you can say planning, land use, land cover map and land use, land cover guidelines. So that would not be applicable to India. Then comes the data quality. So accurate, reliability and completeness of training data directly influence the model's performance and generalization capability. Generalization capability, that is important. I may develop an AI model which would be applicable locally for this study area only or for this study only. But a general model which would be applicable for similar studies across the globe, for that I need accurate data and representative data for across the globe. So obtaining accurate and reliable ground truth levels can be difficult due to limited ground-based observations, subjective interpretations or human errors. Ground truth or the field data is very crucial for remote sensing based survey. So why ground truth is important? To calibrate the remote sensor, to help in remote sensing data correction, analysis and interpretation, to verify and validate the thematic maps generated from remote sensing, that is for accuracy assessment. How we do it? This is in situ measurement in support of remote sensing measurement. I told you earlier that you have to go to field with a GPS and either a handheld radiometer or at least a diary and a pen. So you have to, here for example, using the spectroradiometer, they have actually measured what is the reflectance coming from whatever is present, whatever objects are present on the ground, and returning back to the laboratory, they are feeding this information to the software. Now based on this feedback, the software will classify the image. So similarly, you can see the same operations, but using different, you can say, radiometer or spectrophotometer, they are actually collecting the information. So it has to be geometrically and radiometrically calibrated. Your satellite image, when you are interpreting, if it is not geometrically or radiometrically calibrated, then the accuracy is compromised and the interpretation is going to be wrong. And this ground data collection, these are the various aspects which are very crucial for ground truth or ground data collection. One is timing of field data collection. Suppose my focus is crop yield. What is going to be the crop yield? I am developing a model. So suppose for last 5 years I am going to the field, collecting the ground truth or the ground data. For crop, I have to go into the appropriate timing. For kharif crop, maybe I am going into the month of August or September, early September. Well, imagine if I go into the field in the month of April and that data I am feeding back for this crop yield estimation, what result will I get there when there is no crop in the field. So similarly, this timing of field data collection is very crucial. Same is sampling techniques. Whether I should collect sample, random sample, or whether I should go for systematic sampling, that is very crucial. Samples should be well represented of the class. Suppose in my study area, there are, you can say, 5 types of, you can say, crop. So I have to collect ground truth from all these 5 types of crop. Suppose there are, you can say, 3 water bodies. One water body, one lake is crystal clear. Its reflectance value is different from another lake which is turbid. If I do not collect the, you can say, reflectance value with handheld radiometer, or at least note down any explanation how it has reached to that conclusion or to that accuracy level. As you can see this is the simple artificial neural network model. There are input layer where you are giving all the giving feedback about all the inputs. Then there it is generating hidden layers, more than one, and then it is analyzing the interaction between the input layers and the hidden layers and giving you the output layers. But it is not giving you any explanation how it has reached to that conclusion or that accuracy level. This is simple ANN, artificial neural network. At present, if you see the literature, you will find there is CNN, convolution neural network, there is DNN, there are RNN, and combination of all those. So you can imagine not one such iterative model, but a series of iteration between, you can say, segregated models, they are again combined. That is giving you the output, that is the deep learning. So it is giving you accuracy. If you classify one image using multiple regression, using principal component analysis, using artificial neural network, you will find ANN is giving you maximum accuracy, at least as per the statistics. But then when you are trying to understand it, explain it, then you are failing, because it is not matching with the knowledge that you have gained through your study, through your education. It is giving something which is going, you can say, contradictory to what you actually have learned. But it is giving, on paper it is giving, as far as statistics is concerned, it is giving you highest accuracy. Now you are asking, okay, you have achieved that accuracy, but give me the explanation. No. It is almost like telling you, आपको आम खाना है, आम खाइए, पेड़ के बारे में मत पूछिए. So that is the reason where people started doubting or reluctant to embrace this AI technology. Solution techniques such as model explainability, feature importance analysis, or visualization methods can help shed light on the reasoning behind the model's prediction. And because of this doubt, because of this ambiguity, a new field has emerged that is called explainable AI, which is referred as XAI. Why? What is the background of it? Some, you can say, AI experts, they publish papers and they claimed that they can predict, they can detect possibility of cancer well in advance. That means they now entered into the, you can say, medical field. They can detect, you can say, disease, they can detect, they can predict outcome, cancer prediction. So when they are coming out with some claims, the doctors are not ready to accept it. They are doubting it. And some doctors say, okay, you are telling, but how you are arriving at such conclusion? Because what you are telling me, based on that, if I have to prescribe some medicine and it happens that no, your prediction was actually wrong, so these drugs would have, you can say, negative impact on my patient. How can I rely? Then they realized that without explanation, doctors are not going to accept it. So, the focus was earlier in achieving higher accuracy and further accuracy. Then it diverted to achieving to give much more explanation, interpretation. And that's why this explainable artificial intelligence has came into picture. But what is written, more research is required. It has not achieved that level of explanation that it has achieved in terms of accuracy. Accuracy is 99.9%. Explanation 50%. So that means there is significant gap between the accuracy and the explanation level. So these are the challenges of XAI. Okay. So some challenges are inherent in the AI technology itself. Some challenges are inherent of the remote sensing. Okay, so these are the, you can say, challenges are faced. Then comes, you can say, diversity. I think there is, you can say, time is very short. So diversity is it evaluating and validating the AI models on diverse and independent data sets. What I earlier said, that you have trained your data, tested your data in Siberia or Greenland, which is snow-clad. Himalaya is also snow-clad, Karakoram is also snow-clad, Hindu Kush is also snow-clad, okay, Antarctica is also snow-clad. So, what I wish to say, that the training and testing at one location or based on one set of database may not be applicable equally or may not achieve that accuracy in another, you can say, condition, where the conditions are totally different, inherent conditions are different. So one of the main challenge lies in the availability of diverse and representative, you can say, training data. So collecting a representative data set that covers all possible variations of the target population or the real world is a big challenge. Developing effective techniques to adapt pre-trained models to remote sensing specific features and variations remains an ongoing research area. Another is, you can say, rare and complex events. Here, you can suppose you have given training to AI to, you can say, based on the rainfall and runoff in a river, to model the, you can say, low flow and high flow. But suppose the source of water is not rain. It is the glacial lake burst. Because of that, what could be the situation, what could be the dimension of flow, that prediction capability is not there because it never happened. It is unique event. So if it is not, this feedback is not given during the training to the AI, then AI is handicapped to model it, to predict it. So AI models trained on standard data sets poses challenge in generalizing these, you can say, rare scenarios. So research efforts are focused on developing techniques to handle these rare events and improve the generalization capabilities of AI models. So what I told earlier, this AI is still developing, and particularly in the field of remote sensing, it is still struggling to some extent. So solution is data augmentation, fine tuning and generation of ensemble methods combining multiple individual models, each trained with different algorithms or variations of the training data. Then comes integrity and security. Remote sensing data can be vulnerable to malicious actions. Okay, unauthorized uses, compromise of personal privacy, because you are using very high resolution centimeter scale data. You can imagine that it can breach your privacy. So to address these, robust encryption protocols and secure communication channels should be implemented while transmitting remote sensing data. This is very crucial, particularly we are having, you can say, malicious, you can say, email, or even we are facing this in this, particularly in this era of, you can say, social revolution through, you can say, digital technology. Every day we are facing this. So you can imagine when the remote sensing is intruding your private space. So centimeter by centimeter, that also will be mapped. So biases or inaccuracies in the training data result in biased or unreliable artificial intelligence predictions. So it is essential to prioritize transparency, fairness and accountability throughout the AI model development and training processes. Maintaining integrity in remote sensing data involves multiple aspects including data quality, data integrity and the prevention of tampering or manipulation. So data, you can say, source, as well as from the source itself you have to, you can say, store the storage system and even the server clouds where from data is being shared across the globe, that has to be very secure. And particularly privacy regulations, okay, for example, the, you can say, general data, you can say, privacy regulations that is implemented by European, you can say, Space Agency and European Unions, that may be a guideline for rest of the world. Europe, particularly Germany, is far ahead in this regard. They have already implemented it, that even your personal data, not only remote sensing data, it is very secure because there is a protocol is followed strictly. There are some other issues. I am going very first. One is computational resources. Everybody, every corner of the world, all countries do not have these computational resources or the capabilities or the fund. Hardware limitations is also. Second is interpretability and standardization. Lack of standardization and interoperability among different remote sensing platforms and data formats can hinder seamless integration of AI technologies. Possible solution: establishing industry standards for data formats, metadata and communication protocols will promote interoperability. Encouraging collaborations between technology providers, researchers, and policymakers can help create and implement these standards. This is again at the nascent stage. Human AI collaboration and trust. So the challenge is over reliance on AI without human oversight and understanding may lead to mistrust in the technology. Possible solution is promoting human AI collaboration. That means if you rely totally on AI and empower AI, you can say beyond your limit, then next time means AI will not control you, we will be controlled by the AI. And regulatory and legal frameworks. The rapid development of AI in remote sensing may outpace the establishment of appropriate regulatory and legal frameworks. So the possible solution is develop flexible policy and adaptive regulations. So the conclusion is integration of AI in remote sensing has tremendous potential for practical applications. Efficiency of AI in enhancing data analysis, improving accuracy, and automating processes is already established. AI encounters several challenges, however, that is in data availability, training, optimization, data quality, security of sensitive remote sensing data, uncertainty in real world scenarios, integrity, diversity, etc. So addressing these challenges require further research and innovative solutions to ensure practical implementation of AI-based remote sensing. These are a few references only I have shown here, which are extensively used in preparing this, you can say, PPT. Thank you. I hope I could share some of my understanding of the application of AI and particularly the limitations and challenges of artificial intelligence in its applications into the field of remote sensing and geospatial technology. So in nutshell, AI has, you can say, great potential, but we have to use it with caution. Okay, thank you.
Sir, PPT language ceremony.
Okay. Should I send you email? Okay.
Copy का okay. आपने हमें PDF टा बढ़िया दिखा था, ठीक है? Sir, please.
Thank you so much, sir, for this valuable session. I hope all of you have gathered a lot